Hello everyone, this side Dr. Nitin Sharma from IT department, Ajay Kumar Garg Engineering College. So today I am going to discuss a topic which name is deterministic finite automata to the regular expression. It is basically a topic from the TOEFL subject, that is theory of automata and formal language. So what is DFA? We have already discussed in the previous lecture, like discrete finite automata. So if you are having a finite automata, so you can find a regular expression easily. So there are two popular methods for converting a given DFA into a regular expression. So as here mentioned that the first method is the Arden theorem and the second method is state elimination method. So there are basically two methods, Arden method and the state elimination method. So today I am going to discuss about this Arden theorem. So Arden theorem is basically, Arden is a scientist which is basically given that expression, a solution, a theorem. So today I am going to initially discuss what is Arden theorem and prove that Arden theorem, and after that we can discuss about some numerical questions, how we can find out a regular expression from a given finite automata. Okay. So what is Arden theorem? Arden theorem is popularly used to convert a given DFA to its regular expression. What it says basically, it states that let P and Q be two regular expression over sigma. Sigma like the input symbol like 0, 1 or AB. If P does not contain a null string, this is the condition. If P does not contain a null string, then if we are having that recurrence relation R is equal to Q plus RP. Why I am saying that this is a recurrence relation? Because you can see this right hand side and the left hand side both are having a same symbol. So R is basically calling itself. So that is basically a recurrence relation. So if equation is like this, R is equal to Q plus RP has a unique solution, that is R is equal to QP star. So this is the solution which Arden gives basically. Okay, so this is the theorem. So if our equation is like in R is equal to Q plus RP, then the solution is R is equal to QP star. Now we discuss about how we can prove that that is the Arden theorem. So you can see step by step. So as I understand that this is basically a recurrence relation. So we can just put the value of R in the left right hand side. Okay, so like this Q plus, in the place of R we can just write this Q plus RP. So we can write Q plus RP and the multiply by P. So this is basically the things which is basically we can put the value of R instead of this. Okay, when we multiply, then we can get Q plus QP plus RP square. So this is the equation coming from when we put the value of R. Again, because this is a recurrence relation, so this again we having a R here. So Q plus QP plus R Q plus RP. In the place of R, we can just write Q plus RP and then P square. When we solve this, so Q plus QP plus QP square plus RP Q. So you can see, we just see that there is a things which is basically creating a method like Q plus RP, then Q plus QP plus RP square, then Q plus QP plus QP square, then RP cube. If I can put value one by one to the infinity, so after some time, like we can just put some value and after some time, we can just get this Q plus QP plus QP square plus QP cube and so on. So this is the way the equation is coming from. Okay, so what we do next, we can just take the common from this Q and this is null plus. Okay, so when the Q is common, so here is basically, if I am talking about in the mathematical form, so it is basically coming like 1. But in the automata, 0 and 1 is a input symbol. So if you writing a 1 like in the multiplication in the mathematics, so you can write a epsilon. So like epsilon dot A is equal to, that is A. So it is behaving like a 1 in just like the behaving in a mathematical form. Like we can just write 1 multiply by 10 is equal to obviously 10. So similarly, epsilon dot A is equal to A. Okay. So when I take common from this, so Q is common, so epsilon is here and then P square, then P cube and so on. Okay. So if you can see, what is this? This is basically all the combinations which is coming from the P star. Like P star is having basically the combination of null, a single P, double P, third P, 4P. So all the combinations which can be made by using P star. So this is basically the expression, and plus is, you already know that the plus is basically used for the either this, either this, either this, or either this. So what is this? This is basically a QP star. So this is the things you can just prove that if a expression is R is equal to Q plus RP, then the solution is R is equal to QP star. So this is the way you can just prove that Arden theorem. Got my point? Okay. So initially we discuss what is Arden theorem. Arden theorem is like they state that if a expression is like R is equal to QP, then has a unique solution, that is R is equal to QP star. Okay. How you can prove this? The proving method is like R is equal to QP, Q plus RP, and we can just use the recursion method. We can just put in the values, and after the end of the point, we can just got the answer, that is QP star. Okay. Now, what is the condition basically? Before solving any deterministic finite automata, why I am saying that the deterministic finite automata, why we not use that the finite automata, we can find out the regular expression from the given finite automata. No, we specifically told you that we can find the regular expression for a given deterministic finite automata. Got my point? So, to the use of Arden theorem, following condition must be satisfied. There are two conditions simply. First is, the transaction diagram must not have any null transaction. So, if a automata is having a null transaction, so you can't say that that is a deterministic finite automata. That is a non-deterministic finite automata. So, the Arden theorem you can't apply on a non-deterministic finite automata. You can apply Arden theorem only on the deterministic finite automata. Okay. And the next is, there must be only a single initial state. Obviously, when we create a finite automata, there is only a single initial state. This is not a condition. This is basically a condition of finite automata. Whenever we are going to create any automata, finite automata, so there is only a one single state, initial state, and multiple final state. Okay. Now, example 1. So now we are trying to solve some questions on the basis of this Arden theorem. So you can see in the front of you, there is a finite automata, which you can see there is a two state. First is final state and second is initial state. So A is basically the initial state and B is the final state. Okay. So what are the steps you have to be solve this? Okay. So step by step you can see, first of all, you have to be write the equations. Okay. So how you can write the equation? Equation is like any state equal to, then you can write state plus incoming edges. Okay. For example, A. So for the A is equal to. So I am going to write equation for A is equal to. So how many edges are incoming on A? So we can see there are two incoming edges. Actually, sometime we did mistake. We did not consider this initial transaction. We must be consider this one. Okay. So we can see the arrow sign. So there are two arrow which is basically coming to A. First one is this initial and the second one is this one. Got my point? So how you can write this? So for the null, this is basically null for the initial state. What does it mean? It does mean without giving any input, you are standing on an initial state. So when you did not give any value to automata, you are standing on an initial state. That means it is basically represented by this arrow, and in the equation you can present it by a null. Okay. Second incoming edge is this one. So this edge is coming from the B, and what is the input? 1. If B is having a 1 input, then go to the A state. So this is the way you can just write the equation. So this is the A equation. Second one we can write for the B. So B is equal to A0. Okay. So B is having only one incoming edge, that is this one. So A0. So now we are having here two equations. Okay. This is the step 1. So the step 1 is that you have to be write the equations. After that, you have to solve that. Okay. Solve is just like you can putting the value from one to another equation, like you are having a two equation. So like this is first equation, or we can say that this is second equation. Okay, you can just put the value from the equation 2 to 1, then you can apply Arden theorem, then you can find out the regular expression. What is the condition? Condition is only that the final state equal to must be a regular expression. If I can see this one equation, so B is equal to A0. A0 is not a regular expression. Regular expression is an expression which is having only the sigma variables. Okay, sigma like input symbols. So there is a state. So it is not a, we can say that it is not a regular expression. Okay, so how we can do that? So we can just put this B value in a equation 1. Okay, let's do it. A is equal to epsilon plus, in the place of B, we can write A0, and after that, we can write here 1. You must be understand one more thing here. Whenever you are writing values, you must be know that 0, 1 never equal to 1, 0. So like for this, if you are writing 1, A0, that is wrong. You must be right in the sequence, like in the place of B, we can write A0, then after that, we can write here 1. Okay, so if I can compare, if I can see this equation, so this equation is just like we can compare with the Arden theorem. Arden theorem says that if a equation is like R is equal to Q plus RP form, if a equation in the form of R is equal to Q plus RP form, so it is matched. If you can see, yeah, in the place of R, here is A, in the place of R, here is A, the value of Q is null, and the value of P is 0, 1. Okay, so what is the solution? Solution is R is equal to QP star. This is basically the Arden theorem says that. So what is the solution of A? A is equal to, in the place of Q null, multiply, then 0, 1 star. Or we can say write that 0, 1 star. Got my point? This is the value of A. This is a regular expression. Yes, this is the regular expression, because in this expression, there is only a sigma values. There is no other thing are here, like any state or any other things are here. Only the input symbols are here. Got my point? What we do now? We need the regular expression of the B state, because B is the final state. So what we do? We just put this B A value in the equation number 2. So in the equation number 2, that is B is equal to A0. We can put the value of A here. So 0, 1 star 0. This is the final answer. So 0, 1 star 0 is basically a regular expression for this finite automata. Got my point? So there are basically two steps. First is write the equation. Second is solve the equation by using the Arden theorem. Okay, so you can just put the value from one equation to the other equation to the other equation. This is the way you can solve the problem. Finally, you have to get the regular expression for the final state only. Must be remember that. Other state is having a solution, but this is not the solution. The regular expression is that the final state must have a regular expression. So this is the answer. Got my point? So I think this question is clear. This is very a small question for the understanding. Okay, let me do one more question. For example 2, this is the equation. This is a finite automata. So in each step, we are going to be write equations. So for the equation, we can just write Q1 is equal to, how many incoming edge here? There is only one incoming edge, that is null. There is no incoming edge on Q1. So what we have to be write here? Null. Then Q2 is equal to how many incoming edge here? Only one, which is coming from Q1. So that is Q1A. Okay. What is the equation of that is Q3? Q3 is equal to how many incoming edge here? 3. Write one by one. Q1B, that is Q1B plus Q2A, that is Q2A, then Q3A. Then we can write here Q3A. Okay. So this is the way you can just write the equation. Okay. Which state we need to get the final answer? That is Q3. Okay. So we are trying to solve the Q3, but Q3 is having a multiple stated. So what we have to do? We have to solve one by one. Okay. So Q1 is equal to null. So we have the answer of Q1. Q1 is null. Whenever we are getting here Q1, so we can just put here null. What is Q2? Q2 is equal to Q1A. If I can put this Q1 value null here, so what we get here, that is null multiplied by A, that is A. So Q2 is equal to A. Q1 is null, Q2 is A. Now we can put this Q1 and Q2 in the Q3. So we can just write here Q3 is equal to, if I can put here Q1 is equal to null, null into B is B. So B plus Q2. Q2 is A. A multiplied by A. So we can write here double A plus Q3A. Okay. So this is basically I'm getting here. Now what we have to do? We have to be right here like this. We can just put this value. So we can just write R is equal to Q plus RP. So when I using brackets, so we can get the value of Q here. If I can compare with the Arden theorem, so we can get the solution. So what is the solution? Solution is Q3 is equal to Q P star. P is basically A star. Okay. So this is the final answer. If I can solve this by watching this, so you can see Q3 is equal to B plus double A. Okay. So initially either B or either double A. So either B or either double A. And after that, any number of A here. So you can see the matching is here. Got my point? So initially you can start that kind of problem solving by using the Arden theorem. Once you are expert, once you are solving multiple problems, then you can find out how you can solve this problem. Okay. So you can just see to understand the solution is basically you can get directly from this finite automata. Okay. Okay. I think the topic is clear, but let take one more example. So this is one more example is that is there are only two states, but there are multiple transactions here. Okay. So initially the same thing we can do here. Initially we can write the equations for the equation Q1. So Q1 is equal to, first of all, we have to be write null. Why null? Because this is an incoming edge. How many incoming edge here? There are three incoming edge. First is initial, second and third. You can see the arrow sign. Okay. So Q1B, another is Q1B. Okay. And the Q2A, that is Q2A. This is the way you can just write the equation. Another is Q2, Q1A plus Q2B. Okay. So this is the way you can just write the equation. We want the answer of the Q1 because Q1 is the final answer. So we need to get the regular expression for the state of Q1. So how we can solve that? So if I can try this, so you can see there is no solution I am getting right now here. So what we do? First of all, we are trying to solve is Q2. So Q2 we can compare with R is equal to Q plus RP. Okay, if I can compare this, then the solution is R2 is equal to Q1A then B star. This is a regular expression? No, because this is having a state Q1, but we get the answer Q2 in the form of Q1. Okay, so basically Q2 is I am getting here in the form of Q1. So what we have to do? We have to put this value here. Okay. Okay, let's do it. So Q1 is equal to null plus Q1B plus, in the place of Q2, I can write here Q1AB star and after that A. Okay. After that, Q1 is equal to null plus Q1B plus AB star A. What we have done here, we just take the common Q1 from these two numbers. Okay, so Q1 we can just get here and B is here, AB star is here. Okay, now I can compare with the Arden theorem. So R is equal to Q plus RP. Okay, so it is matched. So what is the answer? Answer is that Q1 is equal to QP star. Q is basically a null. And what is the value of P? P is this one. So we can just write B plus A, B star A. Okay, so because the multiply of null is this, so we can just write here. Okay, so the star is QP star. Got my point? And if I can write A, okay, so I already told that null into A is equal to A, null into A star is also a A star. Okay, so null into A star is basically a B plus AB star A. So this is the final solution. If I can compare this one, so you can see the star, that means it may be null. So if it is null, it should be a final state. Obviously, if I can give a null input, it should be in final state. Okay. If A, then B, any number of B is here, either maybe null, okay, and then A. So A, B star. So this is basically the transaction A, B star. A, B star, A. Okay. So this is basically the equation which is basically represent this path. B may be null, B may be multiply, but initially it should be take A as an input, then reach to the Q state, then apply the B, number of B is here, then go back to the final state with the help of A. So A, B, A. And another is B, either B. So any number of B is here. So either this or and then the star. So many times they can multiply for the equations and then finally get the answer. So this is the way you can deterministic finite automata is converted into a regular expression. Got my point? So this is the way you can convert deterministic finite automata to Arden theorem. So in the examination, there are two type of question. What is Arden theorem? How you can prove it? Prove the Arden theorem, and some questions which is giving to convert a finite automata to the regular expression. Okay. So the today topic is closed. Thank you so much.